This is a tutorial for the special relativity simulation. And when you load it up, there's a couple of guys in ships. And if you click on, whatever ship you click on, that's the perspective you are currently in. So if you click on the bottom guy, he lights up and he's got sunglasses. And this means that you are observing in a ship stationary relative to the Earth. If you click on the top one, you are observing from a ship moving relative to the Earth. So we'll observe from this guy's perspective. The default when you load it up, it's not applying effects of relativity. So if we give him the speed of like 72% the speed of light, he will move away from us, but the clocks will still be in sync. Or if we're watching from his perspective, we will move backwards, as will the Earth, and the clocks will still be in sync. So we can reset the ships and the clock there. If you apply, let's go into our perspective. If you apply time dilation and make him move at the 73% the speed of light, you can see that his clock will run slower as seen from our perspective. Our time will pass normally, but if we could somehow see in his ship, I guess, time would seem to be moving in slow motion. Likewise, if you were the guy in the ship and you look at us, it is us who will seem to be moving in slow motion, and our clock will be lagging behind. Okay, and if you can actually go all the way to the speed of light, and from our perspective, that guy will be frozen in time. And then I suppose from our perspective, the Earth and the other ship will be frozen in time if we're on the ship. Then if we include length contraction, it just adds in that length contraction parallel to the motion. So from our perspective, the ship is also length contracted and things are happening very, very slowly inside. And if it goes up to the speed of light, it is infinitely contracted into a single plane with a frozen clock. Likewise, if we're on the moving ship, from our perspective, everything's normal, but the other ship is moving in slow motion and is length contracted, and we can kind of length contract the entire universe, I guess, to a single plane. And that's how I use the special relativity simulation. I hope you find it useful.